Let's go over our sample final for 152. All right, 5 squared is 25 divided by 6. That's 6 is not going to go in evenly, so it won't be an integer. It's not irrational because this is a fraction, which is what a rational is. So it is a rational, and rationals are real and complex. Cube root of 64. So 4 times 4 times 4 makes 64. So the cube root of 64 is 4. That is a natural, an integer, not an irrational. That would have to be not a fraction. This is 4 to 1. So it's not irrational, but it is rational, a fraction, and rationals are real and complex. Everything but irrational. Okay, number 2. So we have to do, it's tempting to add these first, but order of operations say we've got to look inside the parentheses, and in there we have subtraction and multiplication. Multiplication comes before subtraction, so we have to multiply these two, and we get 10 minus 6. We still have parentheses. We have to do what's inside there. So 10 minus 6 is now we have addition, multiplication, and powers. Powers come first, so 4 squared is 16. Now between addition and multiplication, multiplication comes first, so 3 times 16 is 48. And finally, 5 plus 48 is 53. Simplify and write with positive exponents. So negative 2 is not a power, so it stays in the numerator. 4 doesn't have a power. The x is to a negative 2, so we'll take it across the division line and make it x to the 2. And we have x to the 3 that's already got a positive power, so it'll stay there. And the y's have positive powers, so they stay where they're at. Now, this negative 2 divided by 4, 2 goes into both, so that's negative 1/2. And then we have in the denominator x squared times x to the third. When you multiply, you add the power, so we got x to the 5th. Or x squared means x times x, and x to the third means x times x times x. Repeated multiplication is a power 5x's multiplied. Then on the y's, we have 3 of them multiplied in the numerator and 1 in the denominator. So the 1 in the denominator will cancel one of the 3, leaving 2 y's multiplied. So that's y squared in the numerator. Scientific notation. So the first non-zero digit is 5, so we write 5.2. And then what do we have to do to this to make that? Do we want to multiply by 10 or divide it by 10? It looks like we're going to have to divide it by 10, so we use a negative exponent. And if we divide it by 10 once, it'll be divided by 10 once, it'll be 0.52. Divided by 10 twice, it'd be 0.052, and divided by 10 3 times would be 0.0052. So it's negative 3. This is square root. Didn't have to have the 2 there. That's not 5 squared. That's 5 times the square root of 8 6x to the 6. So we're trying to take out pairs. 5's already outside. 8 is 2 times 2 times 2. So a pair of 2's will come out as a 2. And x to the 6 is 6 of them. So each pair comes out as an x. So that's 1, 2, 3 x's out here multiplied, so x to the third. So we have 10 x to the third, and left inside a square root of 2, a single 2 underneath. We can put the 2 in there if we want. Page 2. Okay, first of all, the degree is the term with the highest exponent, that's 4, x to the 4s. So the degree is 4. And how many x to the 4s do we have? -3, so that's the leading coefficient. Now the term with the lowest power or degree would be the one most powerful next to 0, so that would be the 5x squared. And the one that's most powerful, far from 0, will be the leading coefficient, the one with the degree. So that's -3x to the 4. Okay, number 7. So 3x is times this parentheses, so 3x times 5 is 15x. 3x times a -2x, 3 times -2 is -6, x times x is x squared. There's nothing to distribute here, so we can drop the parentheses. If there was a minus, we'd have to go in and change the signs of all those, but there isn't a minus. Now I'm going to write them in order. So the highest one, the most powerful, is the -x to the third. The next most powerful is the x squareds. And so -6 plus 7 is plus 1x squared, so we can leave the 1 off when it's 1. Then x's, looks like we got one of those. No, we got 15 plus 1, so we got 16 x's, and then we don't have a constant, so that would be the answer. Okay, if we're going to multiply these two, we're supposed to sketch a model of multiplying. So I'm going to go x, I'm going to call that linked x. I'm going to do another one of those, so that's another x plus one more, and I'm going to call that 1. The other direction, I'm going to go an x, so that's about the same as this, and then plus 3, so 1, 2, 3. Now if I finish the rectangle and draw lines where they change from x's to numbers, so this square is x by x, its area is x times x, which is x squared. This one is x by x, so it's x squared. This rectangle is x by 3, so its area is 3x. X times 3 is 3x. 1 times x, this is x, and this is 1, so that's 1x. And 1 times 3, 1 by 3 is 3. So this multiplied out, first times first, is 2x squared, which is this one and that one. We have 6x and 1x. 6x and 1x, that's 7x. And 1 times 3, is 3. So there's it multiplied out, and here's a picture of what's going on to make that. Next one, we have to multiply these and combine like terms. So we got to take 3x times these. So 3x times 2x is 6x squared. 3x times 5 is 15, and there's just a single x there. And then we've got to take that answer. We took this times this and this. We don't take it times this and this again, because we just multiply these two, take that answer times this one. So now I got to take the 6x squared times x, which will be 6x to the third. I got to take 6x squared times the negative 1. So I've taken the 6x squared times both of those. Now I got to take 15x times both of those. 15x times x is 15x squared. And 15x times the negative 1 is negative 15x. And looks like we have a couple of like terms. These are both x squareds. Can't be combined with those. So we get 6x to the third, and minus 6 of them plus 15 is plus 9x squared minus 15x. Okay, next one. We have another one where we're doing similar stuff. So we got to take 5x squared times x squared. So 5 times 1 is 5. X squared, that's x times x. X squared, x times x. So we get x times x times x times x. That's x to the 4th. Or when you multiply, you add the powers. So I took this times this one. Now I got to take it times that one. 1 times 5 is 5. X squared times x is x to the third. Then we got to take the 5x squared times the 3. 5 times 3 is 15, and x squared times no more x's is x squared. So we've taken the 5x squared times all three of those. Now I got to take the negative 2 times all of those. So we get negative 2x squared, negative 2x, and minus 6, and negative 6. Now we combine like terms. There's only this one with x to the 4th in it, so we get 5x to the 4th. There's only this one that has x to the 3rd, so we have plus 5x to the 3rd. These two have x squared, so 15 minus 2 is 13x squareds. That's the only one with x's only, so that's minus 2x minus 6. Excuse me. Now, to simplify something like this, we want to factor. And the first step is to see if there's anything that we can pull out. This is a 5 times x times x, and a minus 3 times x. So there's an x in both of them, so I can write x times 5x. X times that would make 5x squared, minus an x times negative 3 will make negative 3x. Is there anything in common here? It looks like there's a 5 in both of those. So 5 times 5x would make 25x, and 5 times a negative 3 would make negative 15. These look exactly the same. They're added, so we can cancel those because they look exactly the same. They're not added, but subtracted. They're subtracted, they're connected, but the whole group looks the same, so we can cancel, and we're left with x over 5. plot A at -5, 3. 1, 2, 3. Plot B at -3, 0. C is at 3, 6. In parentheses, correct notation for a point. D is at 5, -3. And E is at -5, 0. Now it asks which quadrant is D in. Well, the quadrants go 1, 2, 3, 4. So D is in the fourth quadrant. Or you could write fourth like this. Okay, page 4, or page 3, I guess. We're supposed to graph y equals 3x minus 6. So the slope is 3, and it goes through -6 with a slope of up 3 over 1, up 3 over 1, up 3 over 1, up 3 over 1, and it looks like it's right here. Now, if you don't know how to do it that way, you could always build a little table and say if x is 0, 3 times 0 is 0, minus 6 is -6 for the y. If x was 1, that's 3 times 1, 3, minus 6 is -3. 2 times 3 is 6, by 6 is 0. 0, -6, 1, -3, 2, 0. We're establishing the linear pattern. And I just so happen to have the y-intercept on my table and the x-intercept. Goes through 2, 0, and 0, -6. Then it says graph x equals 7. The line where all the x coordinates are 7. So the x coordinates are all 7 right here in that direction, going on forever, up and down. Solve for x in this. So 5 times 3 is 15. 5 times -x is -5x equals 5 minus 10x. So let's get all the x's on the same side. So I'm going to go plus 10x plus 10x. So now I have 15 plus 10 minus 5 is plus 5x equals, these cancel at 5. I'm going to subtract 15 from both sides. And so I get 5x equals -10. Divide both sides by 5. And I get x equals -2. A homeowner is cleaning carpets and needs to rent a carpet cleaner. Super Clean rents a cleaner for $20. C is the cost, and X is the number of hours. So it's $20 plus 5 times the number of hours, and the number of hours is this. So we're going to pay $20 always, and 5 times the number of hours used. $5 per hour. So there's the cost function. I'll write it as cost is a function of x. Now we're going to do again for Lovely Clean, which rents it for $25, so they're more expensive for the initial rent, but it's only $4 per hour. And determine the number of hours where the rental costs are the same. So we're going to set this cost equal to this cost and figure that out. So 20 plus 5x is 25 plus 4x. Let's get all the x's on the same side by subtracting 4x from both sides. So that leaves it 20 plus 1x equals, those cancel, so it's just 25. Subtract 20 from both sides, and we get x equal 5. And that would be the number of hours. This one would cost the same as this one. If I put 5 there, I get 20 plus 25, $45. If I put 5 there, I get 20 plus 25, $40. $45. Both of them would cost $40, $45. Okay, next page. Jorge drives to work averaging 30 miles per hour and returns home averaging 35. The total time is 1.5 hours. So as we learned in class, how fast you're going, your speed, times how long you go at that speed, like 60 miles an hour for 2 hours, would get you 120 miles, the distance. We want to compare time, so time is equal to, divide both sides by the speed. The time is the distance divided by the speed. Okay. So if they work d miles away and they travel at 30 miles per hour, that's the time going to work. And then the time coming home would be the distance divided by the speed. And those two added is the total time for the whole trip, which is 1.5 hours. Oh, sorry. This is the time going to work. This is the time coming back. Determine the total distance. So now we're going to write the whole equation. D over 30 plus D over 35 equals 1.5. To get this cleaned up, I could just not think too hard about this and multiply everything by 30 and 35. So I'm multiplying both things of this side by 30 and 35 and this. The 30s cancel here and I get 35D plus the 35s cancel and I get 30D equals 1.5 times 30 times 35. So I get 65D equals 1.5 times 30 times 35. 1575 And so the distance is going to be that answer divided by 65. And I get 24.23 is the D, or the distance, the miles. Okay. Solve the following equation by factoring. So when you're trying to solve a quadratic by factoring, you want to get it equal to 0. So I'm going to subtract 8x from both sides. So I get 5x squared minus 8x plus 3 equals 0 if I write it with descending powers of x. So x to the 2, x to the 1, and no x's. I want to write it in order to help with the factoring. So now if I had my strips of paper, I would set -8 with 0, make one of these go up, and make the other one go down. So -9, -10, -11, -12, or the other way, -1, -2, -3, -4, -5, and -7, -6, -5, -4, -3, -2. All of these add up to -8. I might have to do some others, but I'm looking for a pair that multiply to be, let's see, 5 times 3 is 15, positive 15. These would multiply to be negatives. Here multiplies to be positive 15. So I'm going to write x minus 5 and x minus 3. But I need 5x squared, so I'm going to borrow from this 5. I'm going to divide it by 5 and make it a 1, and put the 5 into, this is the inside, so it goes over here. So I still have -5x and -3x, which makes -8x. I do have 5x squared, and -1 times -3 is +3. So this factors to x minus 1 and 5x minus 3. And if I want to get it equal to 0, I have to find an x that makes that be 0. So I write x minus 1 equals 0. So x equals 1. Or I write 5x minus 3 equals 0. Add 3 to both sides and divide by 5. So x equals 3/5 or 1. Now you get to show your proficiency with the quadratic formula. They're already in order, and it's already equal to 0. So my a is how many x squareds? There's 2 of them. Not 2x squared, it's just the number of x squareds, 2. B is the number of x's, there's -5. And C is the constant, which is +1. Quadratic formula is the opposite of B plus or minus the square root of b squared minus 4ac, and both of these parts over 2a. So the opposite of b would be +5 over 2 times a, that would be over 4, plus or minus. Now we have the square root, and -5 times -5 is +25, and -4 times 2 times 1 is going to be negative. 4 times 2 is 8, times 1 is 8, over also the 2a, so that's over 4. So 25 minus 8 is square root of 17 divided by 4. And this is 5 fourths plus or minus the square root of 17 over 4. 5 fourths plus the square root of 17 over 4 is one answer, and 5 fourths minus the square root of 17 over 4 is the other answer. Next page. Write an interval notation. So this is the numbers from -4 up to 9. The numbers between -4, including the -4, so that means bracket, up to 9, not including the 9 because there's no equals. Okay, so we got two separate parts, so we have to write it as two separate ones and union them, group them together. So here we have numbers that are smaller than -4, but not equal because it's an open circle. And here we have numbers from -1. The numbers are got to be greater than or equal to -1. So if I'm going to do it in interval notation, I'm going to say from -infinity with a parenthesis up to -4, not including -4 because it's not equal, union. Now we got to go from -1, so, and we can include it because it's got an equal, it's a solid dot, up to infinity. Okay, we got to solve this. So x minus 6x is minus 5x greater than or equal to 2. So I need to divide by -5. So I get x, I get 2 over -5. But when I do that, this is greater than or equal, but when I divide by a negative, I need to flip it so it's less than or equal. Or, if you will, from -infinity up to -2/5, including that. Interval notation, inequality notation. Either one of those answers. Okay, so function notation. Do we know how to calculate f when x is 2? So that's going to be 2 squared plus 2 times 2. I replace the x there and the x there with 2. So I get 2 squared 4, 2 times 2, 4. So I get 4 plus 4 is 8. Now we're supposed to do f of -3. So -3 squared is 9. And 2 times -3 is -6. So that's what f of -3 is, and we're supposed to find f of that. 9 minus 6 is 3, so we've got to find out f of 3. So 3 squared is 9, plus 2 times 3 is 6. 9 plus 6 is 15. Now we're supposed to put a plus 2 in for the x's. So that's going to be a plus 2 squared plus 2 times a plus 2. I put a plus 2 in for that x and a plus 2 in for that x. The part C says simplify that. So we've got to multiply a plus 2 times a plus 2. And we've got to multiply 2 times the a plus 2. So a times a times 2, 2 times a 2 times 2 plus 2 times a, and 2 times 2. So it looks like I have an a squared, that's the highest power of a. Then I have 2a plus 2a plus 2a, so I have 6 a's. And I get 4 plus 4, which is 16. Okay, more work with function notation. G of 7. 7 plus 2 is 9. Square root of 9 is 3. K of negative 3. So this is a picture of K. If I go to negative 3, the Y is 1. Then I got to find out, what do I put in for X to get this to come out to be 8? So I'm going to write 3x minus 4 equals 8. Add 4 to both sides. And divide by 3. I'd have to put 4 in for the x. 3 times 4 is 12, minus 4 is 8. This says put 2 into f. 3 times 2 is 6, minus 4 is 2. So this works out to be 2. So I got to figure out g of 2. 2 plus 2 is 4. Square root of 4 is 2. So now I got to figure out k of 2. This was 2. When I put that into g, I got 2. And now I got to find k of 2. So I'm going to come over here and go to 1, 2, and it looks like it's really close to 0. Now it says find h of negative 3. Negative 3, h of it is 0. So I got to find k of 0. And of 0, k is negative 2. And to find f inverse. So this is y equals 3x minus 4. So I'm going to switch the y's and x. So instead of making this y, I'm going to make it be x. And this is going to be 3y minus 4 and solve for y. So I add 4 to both sides. Divide by 3 on both sides. And that's what f inverse is. X plus 4 quantity all divided by 3. Next page. So this is my f of x. Oh, and this should say next 2. I changed it but didn't change the wording. So what happened to this to make this? Well, it looks like this went down to the bottom and this went up above. So it looks like it's this thing flipped over the x-axis. So that's vertically working, so it's on the outside, so it's f of x, and changing it, flipping it, so it's a negative f of x, or negative 1 f of x. Now this is working also vertically, so it's on the outside. This was up 2, it's now up 4. This was down 1, so it's now down 2, so it's twice as far down as it was, twice as far up as it was, and horizontally there's no change, so it's going to be 2 times f of x, and it's not moved up or down because it's same where it's crossing the line, still crosses at the same places. Number 27, f of 5. 5 is in this domain, so we're going to do 5 plus 3, 8. F of 0. 0 is not less than 2. It's between negative 2 and 5, so I'm going to use this one, and so f of 0 is just 3. And f of negative 7. Negative 7 is less than negative 2, so we got to go negative 7 squared. So negative 7 squared is negative 7 times negative 7, which is plus 49. Next one. The slope is the number that's times x, so that's negative 2. A negative makes it decreasing. The number times x is the 3. It's positive, so it's increasing. It's a positive slope. Write the equation through these points. So I need the slope, which is change in y. So it went from 3 to 5, so it went plus 2 over, went from 2 to negative 3, so that's minus 5. So the slope is negative 2/5. So my equation is going to be y equals negative 2/5 x plus something. We don't know this number. So we got to figure that out to finish this. So I can either put in 2 or the negative 3 for x. I'll just choose 2. So I'm going to write negative 2/5 times 2 plus something that I'm trying to figure out. It's got to come out to be 3. So negative 2 times 2 is 4, negative 4, and 5 times 1 is 5. So this is negative 4/5. So I add 4/5 to both sides, and I get b is equal to 3 4/5. So that's what I have to write here. And there's the equation. Okay, number 31. So if t is the number of years after 1950, then this would be t be 0 at 1950, and 2000 would be t equal 50. And so we have the points 0, 500, and 50, 2500. So the change in y was plus 2,000, and it went up 2,000 people in 50 years. So 50 goes in there 40 times. So 40 people per year. I did that in my head. I want to check that. So I'm going to pull out a calculator and do 2,000 divided by 50. Yep. Okay. So my equation is the population after some time would be 40 people per year times the number of years, let's call that t, as I said to do, plus the y-intercept, and that was 500. So now to find the population in 2025, that's 75 years after there. So I'm going to go 40 times 75. 40 times 75 plus the 500, and we get 40 times 75 plus 500, showing my work, comes out to be 3,500 people. That's what the model is predicting, if it's going up 40 people per year. Okay, and now the last page. On this one, I've given some data for a ball drop. These are measured in centimeters. Determine the slope. So graph the data first. So I'm going to go down here and graph the data. So I got to get from close to zero to 300. So I'll just use this as my x-axis. So if that's 0, I'll do 40, 80, 120, 160, 200, 240, 280, 320. And to label my units, this is drop, height, and the units are centimeters. Now this way, I need to go up to 210, so I can just do the same kind of thing. 20, 40, 60, 80. Make it easier, I'll just do 100, 20, 40, 60, 80, 200, 20, 40, 60, 80, 300. And this is the bounce height. Also in the units centimeters. So I have, that's 20, 25 is about there, and 18, that's 20, so 25, 18 is about there. 50, that's 60, so 50 is in the middle, and 34, I'm looking at the data up here, 50, 34, 20, 34. Next one is 80, 52, 80, 20, 40, 60, 52. Next one is 168, 100, 20, 40, 68, almost 70. 200 is 144. 200 is 20, 40, 60, 80, 100. 20, 44. And 300 is 210. 300 is 20, 40, 60, 80, 100. 20, 40, 60, 80, 210. 220 would be there, so 210. Now I need to draw a line through those points. Now I'm not trying to hit 0 per se, I'm just trying to get as close as I can to all these points. So I'm gonna do something like that. And looks like it does hit 0, 0, but it doesn't have to. Now to find the slope, I'm going to look for two places that are close to, right, well there's 0, 0 works pretty well. And there's one, a 200 and 140. Drop it from 200, bounces to 140. And we're going to use 0, 0 as a point. So the change in the y goes from 0 to 140. So the slope goes up 140 centimeters as the x goes from 0 to 200, which is a change of 200. Centimeters will cancel, so it's going to be 140 over 200, which is 7/10 or 0.7. That reduces to 7/10 or 0.7. And since these both units cancel, there's no units on that. Oh, that's up here, 0.7 with no units. And what's this mean? It means the bounce heights on the bouncing here, this, since the units cancel, it becomes a percentage. But if it didn't cancel, then we wouldn't be going percentage. So, or we can say it bounces 7/10 of a centimeter higher for every 1 centimeter higher dropped. Or for every 7 centimeters higher dropped, it bounces 10 more centimeters inwards. 7 centimeters more bounce for 10 centimeters more height dropped. That's the meaning of the slope in this case. Y-intercept, 0, 0. And that's 0 centimeters, because the y-intercept is this axis, and that's measuring centimeters, so it's 0 centimeters, and it means if dropped 0 centimeters, the ball bounces 0 centimeters. Okay, so we got all that. Now it says use technology to find the Grecian line. So I didn't ask you to find the line up here. So now we're just going to get the technology to tell us the line. So we're going to go to Stat, Edit, and I'm going to put in, I'm going to clear that list, come down and go up there and clear that list and come down, and I got 25, 50, 80, 100, 200, and 300. And the y's that go with that are 18, 34, 52, 68, 144, and 210. Okay, so now we'll go to Stat, calculate the line using list 1 and 2. And it says the slope should have been 0.71. We got 0.7 even, but it's saying the bounce height based on the drop height, I'll call that D. The bounce height would be calculated as 0.71 or 71% of the drop height. And the y-intercept is minus plus a negative 1.7 centimeters. So it didn't come up with 0, it came out with 1.7, slightly higher than we had it on our graph down here. Okay, and it asks for the R value. And the R value is 0.999, which means it's a very good fit. But I just asked for it. You didn't have to tell me that. It just says you find the regression line and the R value.